All right, number 13 says evaluate each logarithm expressed without using a calculator. So we know there's an invisible 10 there. We know there's an equals x here. Start here, go there. 10 to the x equals 1 million. So we could quickly just say that's 10 to the x equals 10 to the 6th. Common bases, happy places, so x equals 6. This here, when you see the natural log, you know there's an implied base e. Then you go from here to here. E to the x equals whatever's in that spot. E to the negative 7, so the bases drop off. X equals negative 7. There's a e here, because of the natural log, equals x. E to some power equals 1, so it would look like this. E to the x equals 1. Well, anything to the 0 power is 1, so x equals 0. Stick your x in right here, base, exponent, answer. You can either just look at it and say x equals 3, or you can go common bases, happy places, and then you'd get x equals 3. There's an invisible 10 right here, equals x. 10 to some power could never give you a negative, so that would be no solution. If I write it like this, there's no way you can raise 10 to some power and get a negative, so that's just no solution. This one's going to require a little bit more work. That's a 2 to the x power equals 1 over the 5th root of 8. So common bases, happy places. I'm going to turn that 8 into 2 cubed. So really this turns into 2 to the x equals 1 over, and I'm going to put that power over the index, 2 to the 3/5, and then I'm going to bring that up. So that'd be 2 to the x equals 2 to the negative 3/5. So x equals negative 3/5. Number 19 is just testing you on your graphing. So that right there is over the x. That right there is a vertical stretch by a factor of 3. That's going to be left 1. And this is going to be down 2. Not bad. So we got to express these two logarithms as a single logarithm. So this is where we're talking about marriage. So I said to look for law 3 first. So that little 2 we're going to put right here and then get rid of it. So we have power, power, power to power. We get natural log of x to the 4th, y to the 6th. Same thing here. I'm going to bring that 3 right here and get rid of it. So it's minus the natural log of x cubed, y cubed. Remember, subtraction means division. Here comes the marriage. Natural log of x to the 4th, y to the 6th, x cubed, y cubed. And now we got to simplify this. So that would be the natural log. There's more x, one more x in the top, 3 more y's in the top. So that just reduced to natural log of x, y cubed. Number 21 is asking us to solve it. So we got to turn it into an equation. 3 to the 4th equals this stuff, 1 minus x. 3 to the 4th is just 81. So 81 equals 1 minus x. Subtract 1, subtract 1. 80 equals negative x. So positive x equals negative 80. Last but not least, number 22. I encouraged you guys to clean up the messy side, and this is a mess. In other words, we're going to apply the marriage rule to this. The 2 shall become 1. So subtraction means division. This is just sitting there, so we'll just bring it along for the ride. And then this turns into log 2 over 3x plus 1. So now this is where the logs just disappear. And we end up with 4 equals 2 over 3x plus 1. Multiply that by 3x plus 1, so those cancel. We're going to multiply this by 3x plus 1. Distribute, distribute. So you get 12x plus 4 equals 2. Subtract 4, subtract 4. 12x equals negative 2, divided by 12, divided by 12. That would reduce to negative 1/6. That's it.